Alright, welcome to part 2 of my videos on the topic of C++ namespace. This part of the tutorial is going to use some examples based on NASA and NOAA. It is going to be a continuation of the first video. If you have not watched that video, I recommend you go and watch it. If you have, then you can continue with this. You can also continue with this if you have not watched the first one, but to understand everything fully, I recommend you watch both. But before we continue, if you have not subscribed to this channel, please subscribe to the channel. Alright, for us to create this NASA application, we are going to use 3 different files. One will be the main app, one will be the header file for NASA namespace, and the other one will be for the NOAA namespace. That will also be a header file. So now I'm going to create a file here. New. It will be a .h file. I will name it solar_system.h. Great. I'll create another one. I will name it ocean_level_watch.h. Hit enter. I will create another one. This is going to be our main.ccp file. I will name it NASA app.cpp. Hit enter. Great. Now we have the 3 files. We don't need this one for now anymore. We'll close that one. Now we have these 3 files. This one is a .h file. It's going to be a header file. This one is a .h file. It's going to be another header file. While this one is a .cpp file. This will contain the main function for the application. I'm going to leave some comments here. Void size, void semicolon. Leave another one here. Void average temperature, semicolon. Another one, void composition, void composition, void semicolon. These are some of the functions that we are going to use in our namespaces. That is for the solar_system namespace and the ocean_level_watch namespace. Okay. I'll copy this one and paste it in this one because we will need it here as well. So for now, let's concentrate on this one. Leave a comment here. The solar system header file. Okay, it's going to be a header file. Let's just define it. If not defined, solar_system_h, then define it. And let's end it. And if. So this one opens it and this one ends it. Okay. Here we are going to add some header files. Include IOStream, include string. Now I'm going to define this one, so I will uncomment it. As we are not using the standard namespace header file here, we will use the std : scope resolution operator. Std : string. I am going to create an array here for planets. Equals Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. I will add Pluto. I know geographers have a story about Pluto, but I'll just add it here now, though it's not officially considered a planet anymore. I'll leave a comment here. Let's access elements of the planets array. std : cout the planet planet 0 has ... planets 0 has ... This is the message we are going to get there. This can be any number that we print out, any planet here, but I just set it here now to 0, that we print out, of course, this one here. Now I'm going to do something with the second function here, average temperature. std : cout the average temperature in planet S is std : and line. Now I am going to do something with this function too. std : cout planet S is composed of ... and line. That is all we need for now for the solar_system.h header file. Save it. Now let's add some code to the ocean level watch.h file. I will leave a comment here. The ocean level watch header file. I will say if not define ocean level watch, ocean level watch H, then define ocean level H. Now let's end if and ocean level watch. Let's add some header files too. Include IO stream, include string. Now I'm going to add code to these functions. Let's begin with size. Because we are not using the standard namespace library here, we have to use the std : scope resolution operator as well. std : string. I will create an array here and name it ocean body. Atlantic Ocean, India Ocean. I will put the complete code on GitHub and I will put a link to it in the description box for this video. Pacific Ocean, Arctic Ocean, Antarctic Ocean, semicolon. See here, access elements of the ocean body array, which is this one that we've just created. And to do that, std : say out the size of ocean body, put a 0 here, could be anyone, then is ... std : end line. Save it. We are done with that. Now let's add some code to this function. We uncomment it. Leave a comment here. The average temperature function. This one is the size function. std : say out the average temperature in ocean S is std : end line. So that's fine for now. And now I'm going to add code to the composition function. Let me first uncomment it. I'll leave a comment here. The composition function. std : say out ocean S is composed of salt water, std : and line. Save it. That's fine for now. If you look at these two header files, we have actually created functions in them, but at the moment we have not actually declared them as namespaces. We have not declared any namespace in this one, and we have not declared any namespace in this one. We will come to that in a minute. first. Now let's add some code to the NASA app.cpp, which is the main part of the code. This is the main part of our application. The main function will be added to this nasa.cpp file, and we will add these two files to it as header files. Let me leave a comment here. The main application, that is main the CPP. I'm going to add some header files, include IO string, include string, int main, return 0, semicolon. So this is just a standard C++ code for the main application. Nothing really special about this for now. We are going to add some more code to it later. But before we do, let's add the header files. Now let's add the two header files to our main.cpp application. Include double quote solar underscore system dot h. That's for this one here. Now let's add this one. Include double quote ocean underscore level underscore watch dot h. Save it. Now we have successfully added these two files to our main.cpp file as the main application. Now that we have added these two header files, we can also declare using namespace NASA, using namespace NOAA, just the way we use the using namespace standard. That is using namespace NASA, using namespace NOAA, using namespace std standard. So we are now in a position to use our own namespaces because we have added these two header files. So I'm going to delete this one because I'm not going to use them this way, but this was just to demonstrate to you that we are now in a position to do this. Now with these two header files added, let's try to access one of the functions from the header files. I will first of all try to access size, semicolon. This code will fail. This will not work. Will not work at this stage. The reason for that is obvious. I won't tell you at this stage why it will not work, but let's see the error messages we are going to get when we compile it. Then we will come and fix the error messages later so that it will work. Now let's compile it. G++. Run NASA app. NASA app.cpp. G++ -0 run NASA app.cpp. This is what we are going to run, but for now let's compile it. Exactly. Here we have some errors, and they are very many. What are the error messages that we are getting? It says here On line 10, on the ocean level watch, redefinition of void size. Solar system, void size, previously defined here, void size. This one, line 19, redefinition of void average temperature. So we are getting error messages about redefinition and previously defined functions. The reason for that is easy to spot. We are getting those error messages because here we have not actually specified any namespace. For example, now I am going to create a namespace here. Leave a comment here. Define a namespace. And here I will add as well. Define a namespace. So for this one now, let's create a namespace, because this one is for the ocean level watch, which is for the NOAA. I will say here namespace NOAA. Open the bracket here. Then come and close it here. That's fine. Save it. Now I have added a namespace to it here. So I will save it. I'm going to compile the code once again. Exactly. It was compiled successfully. Now let's run it. Run NAS app. Exactly. It's working now. It says here the planet Mercury has. So it's printing out this one. And where do we have that function? We have that function inside our solar system. This one here. The planet Mercury is in position 0. That's the element in position 0. So the compiler now understands that we have a namespace for solar system and we have one here for ocean level watch. So there is no clash now between these two, because here we have specifically given a namespace to this file, ocean level watch, whereas here we don't have any namespace for this one yet. That is why the compiler is choosing that one, because both header files are added. If I want to access the one now for the ocean level, I will have to use the namespace scope resolution operator. Now it works as a namespace has been defined for one of the header files, and I'm going to leave this one as it is. So to access this one, the one for the NOAA namespace, we have to say here NOAA : size. Now let's compile our code and run it again. Great, it was compiled successfully. Now let's run it. Exactly. The planet Mercury has, the size of Atlantic Ocean is, so NOAA size is actually the size of the ocean body. The element in position 0 in the ocean body array is actually Atlantic Ocean. So with namespace, we have been able to avoid conflicts between the header files. Works. So the second one now, so for this one, let's define the namespace too. Namespace NASA. Namespace NASA. And let's close it here. Great. Now our two header files have a namespace each. Namespace NASA for the solar system header file, namespace NOAA for the ocean level watch header file. And with these two namespaces, we can avoid clashes, conflicts between the two files when we use them in our application. Now let's nest our namespaces for the solar system. Let's nest it. I will leave a comment here. Nesting the solar system NASA namespace. So this namespace NASA is what we are going to nest here. I will say here namespace space exploration void mission std : say out the Apollo's project helped Americans to std : end line std : see out land on the moon and returned to Earth safely. std : end line. The Apollo's project helped Americans to land on the moon and return to Earth safely. That is on the website for NASA. I will put a link to it in the description box for this video. We should also add void here. Now for us to access this function, we have to access the NASA namespace and then access the space exploration namespace. Here we say NASA : space exploration : mission, and let's save it. Let's compile our code and run it. Okay, we've got an error message here. It says NASA app.cpp line 11 error size was not declared in this scope. What that means is here we have to specifically say NOAA size. So I'm just going to comment it out. Now let's compile it again. Great, it was compiled successfully. Now let's run it. Exactly, it works as expected. The Apollo's project helped Americans to land on the moon and return to Earth safely. So this is how we use namespace within a namespace. Okay, I think I can just leave this comment as it was before so that we know what it's doing. We said before, will not work. Yes, the reason for that is we have not actually used any namespace. It is not associated with any namespace. That's why it will not work. Here it is associated with a namespace. It works. Okay. Still on namespace nesting, we can add another namespace to the NASA namespace in the solar system file. It is very important to note that when you are nesting namespaces, use the closing curly brackets correctly. Otherwise, you will get some error messages if you mismatch them, if you match them wrongly, or if you close them in the wrong places. This one is closing the NASA namespace, and this one is closing the space exploration namespace. For us to add another namespace now, we have to add it before the closing curly brackets for the first two. We'll leave a comment here. Close your namespace, closing curly brackets correctly and in the right places. Close your namespaces, closing curly brackets correctly and in the right places. Okay. Nesting namespaces. This time I'm going to add another one. Void Apollo underscore mission void. So now this curly bracket closes this one for this namespace, this one closes the one for exploration, and this one closes the one for NASA. std : say out, say new line, Apollo missions, std : end line, std string. Going to declare an array here, and I will name it mission norms, and it's going to contain 14 elements. Missions array. Let's assign values to the mission norms array. Mission norms 0 equals Saturn rocket test flight, semicolon, mission norms Apollo Saturn accrued missions, mission norms 2 Apollo 1 mission, semicolon, mission norms 3, there should be quotation marks here, Apollo 7 mission, mission norms 4, Apollo 8 mission. Based on the information about their project on their website, it's Apollo 1, then jump to 7, 8, and so on. I don't know what happened to Apollo 2 to 6, so it could be there was no mission like that, but this is the information they have about the Apollo mission on their website. Mission number 5, Apollo 9 mission. Mission num 6. Apollo 10. Mission. Mission nums 7. Apollo 11 mission. To save time, I can copy this one, paste it right below it a couple of times, and I'm going to change some values here. 8, Apollo 12, 9, Apollo 13 mission, Apollo 14 mission, 11, Apollo 15 mission, 12, Apollo 16 mission, 13, Apollo 17 mission. So these are the correct missions about Apollo that they have on their website. Now with the array mission nums created, let's use a for loop to print out all the elements in that array. Print out all the elements of the mission nums array with a for loop. For auto I in mission nums std say out I std colon end line. So for us to access this function inside the solar_system header file, we have to use the namespaces according to the structure in which they were created. So that will be NASA space exploration Apollo mission. So let's print that out. NASA space exploration Apollo mission. Let's compile our code and run it. Great, it was compiled successfully. Now let's run it. Exactly. So we have everything here printed out. Apollo missions, Saturn rocket test flights, Apollo Saturn uncrewed missions, Apollo 1 mission, and all the way to Apollo 17 mission. So this is how you nest namespaces and at the same time access nested namespaces in C++. So you follow the order in which they were created in your application. This is a namespace, this is a namespace, and this is a function inside this namespace. See, nesting namespaces and using functions. That's the okay, that's for that comment. Here for the namespace space exploration, there are so many other functions that we could use, but I am not going to add them. I'm just going to leave some comments here. So all these are functions inside the NASA application. We won't be able to define all of them here. I just listed them out here. You can also define any of them in your application to test that you really understand what is going on or what we are doing here. Yes. Function prototype for some other NASA application functions. These are some other functions that we could use in the application. We can use an alias for a namespace. For the ocean level watch, we can create an alias for that. We have already added it. We have already added the header file, so we can create a namespace for that. To do that, we say namespace OLW, which is for ocean level watch, equals NOAA. The namespace here for the ocean level watch, we have a namespace here, NOAA. Now that we have added it to our program, we can create a namespace for it. I will leave a comment here. Creating a namespace alias. So from the NOAA namespace, we have an alias now, which is OLW for ocean level watch. Let's use that in our application. We say now OLW, the composition, we are going to call the function from the namespace NOAA, which is now abbreviated or giving the alias name OLW. Now let's compile and run our application. Great, it was compiled successfully. Now let's run it. Exactly. Ocean S is composed of salt water. And now, if we actually look at the composition function inside the ocean level watch, it should be exactly what was printed out there. That is actually the text that was printed out. Ocean S is composed of salt water. So this is how you can use an alias for a namespace. It's just a synonym for the same namespace that we just used here. We can also do namespace nesting here with this NOAA namespace inside the ocean level watch header file. So here namespace nesting. That will be namespace exploration void mission void std : say out std : see out England std : see out So to access the mission function inside the namespace exploration within the NOAA namespace in the ocean level watch header file, we will have to follow their structure of declaration. So to do that in our application, we see here OL : exploration : mission. Now let's compile our application and run it. Great, it was compiled successfully. Now let's run it. Exactly, it was printed correctly. NOAA Ocean Exploration explores unknown or poorly known areas of our deep ocean, making discoveries of scientific, economic, and cultural value. Again, this is about how to nest namespaces and how to access nested namespaces. In our ocean level watch header file, here, one last thing, we can add another function to the exploration namespace in the ocean level watch header file. That will be for ocean mission. Here we add ocean mission function to the exploration namespace. Void ocean underscore mission. I am going to use a vector here. Because I'm going to use a vector, I'll add it as a header file. Include vector and now we will use our vector here, std : vector std string. I will name it voyage. Voyage.pushback 2010 exploration. On the NOAA website, this is how they listed it. Voyage.pushback 2011 exploration. Voyage.pushback 2012 exploration. Voyage.pushback 2013 exploration. Voyage.pushback 2014 exploration. Print it out with a for loop. For int I equals 0. I is less than voyage dot size I plus plus std : say out voyage I. End line. Okay, what is going on here is easy to understand. Now here we have created a function named ocean mission, and it is a vector we are using. It is of type string and we gave it a name voyage. So voyage.pushback, we just added this content to it. Exploration. So 2010, 2011, 12, 13 and 14 exploration. That is what they have on their website, on the NOAA website. Here we are using a for loop to print out the content of the voyage vector. To print this one out in our application, now let's use the OL exploration ocean mission. That is the name. I am going to copy it and paste it right here. Then this will be ocean underscore mission. Yes, our function is called ocean underscore mission, and this is the alias. Then this is the exploration namespace, and this is the ocean mission function. Let's compile it. Great, it was compiled successfully. Now let's run it. Exactly, it was printed out correctly. 2010 exploration, 2011 exploration till 2014 exploration, just the way we created our function in the ocean level header file. So we have successfully accessed this function in our application by using the namespace and following the process in which they were declared. So by using the scope resolution operator, we were able to print out the ocean mission function inside the exploration namespace, and the exploration namespace is inside the NOAA namespace, which we have now used an alias for. The OLW is an alias for the NOAA namespace inside the ocean underscore level underscore watch header file. So in this tutorial, we have had an in-depth look into the topic of namespace in C++. Namespace is a very important part of the C++ programming language. I hope you learned something from it. Thank you for watching. Subscribe to this channel if you have not already subscribed to it. Comment on the video, give it a thumbs up and share the video. I will put the complete code on GitHub, and I will also put a link in the description below to the complete code on GitHub. Bye for now.